Okay, so we live in a world where AI can whip up these perfect, flawless images in like a matter of seconds, right? Well, today we're going to look at the total opposite. Let's dive into this fascinating and, yeah, kind of strange world of imperfect images and ask a really simple question. What value could they possibly have?
All right, take a look at this. It's called a remarkable apparition, and you can see why. It's hazy, it's not clear at all, and it's definitely not perfect. It was captured using something called Instrumental Transcommunication, or ITC. Now, don't worry about the term for now. Just look at the image. It's ghostly, it's weird, and it feels like it's from another universe compared to the crisp digital stuff we see every day.
And that really gets us to the heart of what we're talking about today. In an age where we can create picture-perfect worlds with a simple text prompt, you have to wonder, if AI can make technically better images, then what on earth is the value of this?
To even begin to answer that, we have to completely reframe the way we're comparing them. This isn't just about looking at two pictures. We're talking about the perfect versus the improbable.
Here it is. This is the fundamental difference. The big idea you need to grasp. An AI image is constructed. It's built from data. But an ITC image, according to the source, is an event. It's not a creation. It's the recording of something that actually happened inside an experimental setup. Let's break that down a bit more. Think about it. AI images start from a position of incredible knowledge, right? They have massive databanks, they understand statistical probabilities, they know what a face is supposed to look like. ITC, though, it starts with the complete opposite. It works with noise, with instability, with what the source calls poor means. It's not actively creating anything. It's trying to let something emerge from the chaos.
You know, the source gives some really great analogies for this. Judging an ITC image on its visual quality next to an AI image, it's like comparing an EEG trace, that raw, spiky data from the brain, to a beautifully illustrated diagram of a brain. Or, it's like comparing a faint, staticky radio signal from deep space to a perfectly mixed studio recording. They're just not playing the same game.
And that gets to the real goal here. The whole point of ITC was never to make art, to make pretty pictures. The value, as the source argues, is in something way, way rarer: organized improbability. It's about seeing a face suddenly appear out of a field of noise where, by all accounts, it has no business being. So the question isn't, is it a good-looking image? The real question is, wait, how did that even happen?
So let's go a little deeper now into the philosophical side of this, into what we can call the power of flaws, where being imperfect is actually its greatest strength.
The source has this great way of describing AI as a sophisticated mirror. I mean, it's incredibly powerful, but at the end of the day, it can only reflect, remix, and recombine what we've already shown it. It takes what's in the world and gives it back to us in new ways. Its perfection, in a sense, is also its cage.
ITC, though? It takes the exact opposite approach. It stumbles, it fails, it produces these broken little fragments. And because of that, it can only suggest something. It can never assert it. Its real value is in that fragility, that hesitation. It's not a statement, it's a whisper.
And all of this leads to a really powerful line from the source material. Fragments are hard to fake. Perfection is not. I mean, think about that for a second. In a world where perfect fakes are getting easier and easier to make, maybe a genuine fragment, something that's incomplete, that's struggling to even exist, carries a whole different kind of truth.
So ultimately, the image you see isn't even the point. It's just a byproduct of a much deeper question. The real investigation is about limits. It's about persistence, about trying to communicate across some kind of barrier. AI is already here, on our side of the limit. It doesn't need to cross anything. But ITC, by its very nature, is the attempt to make that crossing.
Okay, so that's the philosophy. And it's a cool idea for sure, but you might be thinking, is this all just talk, or is there something we can actually measure here? Well, let's put these images under the microscope and find out.
So that brings up a really concrete technical question. Can we actually find a measurable difference in the way these images are built in their informational structure? Instead of just relying on how they feel, the source sets up a pretty simple, repeatable experiment.
So here's the setup. It's actually pretty straightforward. You take two images. One is just a normal digital photo of someone, and the other is a trans image, one of those vapor-like apparitions we saw earlier. The experiment is simple. You just run both of them through the exact same set of standard image processing filters and see how they react. First up is a high-pass filter, which is designed to pull out fine details and edges. And whoa, look at the result. The original photo on the left, it holds together. You can still clearly see the face, but the trans image on the right, it just falls apart.
The features dissolve into this blurry shape. That suggests the information that makes up the face is way less stable.
Okay, next, the Find Edges filter. And this is where it gets really interesting. On the left, the photograph gives us these solid, continuous lines that map out the face. But look at the transimage. We're seeing exactly what we talked about in the philosophy part, fragments, broken, incomplete traces. The lines can't even form a complete shape.
And this last test is pretty striking. The maximum filter basically makes bright areas bigger. You can see it really messes with the structure of the normal photograph. But the transimage, it barely changes at all. The source suggests this is because there just isn't enough dense pixel information there for the filter to grab onto. It's another sign of just how fragile it is.
So what this all shows us is that it's not just a subjective feeling. These simple, repeatable tests give us actual visual proof that these transimages have a lower structural density. They're just not as informationally solid as a regular photograph, even if they look kind of similar at first glance.
So for our final section, let's bring it all home and see how this hard technical evidence loops right back around to that big philosophical question, what is it that AI can never do?
This right here is the big connection. That fragility we could actually measure, the low density, the broken edges, that's not a flaw. That's the physical proof of the image's philosophical value. It's tangible evidence of something struggling to come into being against all odds.
So now you can see why asking which image is better is it's the wrong question. It's a total trap. The source material is pushing us to forget that comparison and ask a much more interesting question instead.
Because for all its power to create perfection, the source argues there are some things AI just can't do. It can't witness an improbable event emerging from pure noise. It can't record fragility, because its entire design is about creating coherence. It can't demonstrate what it's like to persist against the odds. And maybe most importantly, it can never replace the human courage it takes to investigate something that offers zero guarantee of success.
And so, that's the thought we're left with. Instead of wringing our hands and asking what an imperfect image is worth in our new age of AI, maybe the much better question, the one that pushes us forward, is to look at the boundaries of our own incredible technology and ask, what can AI never do?